morning and welcome to this year's edition of the JCon and my talk about Supersonic Subatomic Mocking. My name is Schwörer. I work for Novatech Consulting, and to say it right up front, we use Spring Boot and Spring Cloud really often in our projects, and we're happy to use it and think they are great frameworks. Nevertheless, within the last months and years, we've seen that there are other frameworks like Micronaut, Ktor, or Quarkus that seem to be very interesting and relevant for us. And when you come with your Spring Boot or Spring Cloud background and you switch to these frameworks, some things feel immediately very familiar, very easy, and some things are a little bit different. And that's what my talk is about today, how to test parts of your application, of your Quarkus application, written in Kotlin with certain frameworks. So what can you expect from my session today? Well, I try to give you an introduction how to create tests for a Quarkus app written in Kotlin. Or to be more precise, we're going to test parts of your application. So it's not about creating an end-to-end test where you test your application, let's say, from your API to your database. It's rather testing a service or a repository or a part of your application and mocking other stuff away. So as the application is already written with Quarkus and Kotlin, we're going to use Kotlin for creating the tests as well. And we're going to use JUnit or JUnit 5 and MockK to mock certain things. If you heard of these technologies, Quarkus, Kotlin, JUnit and MockK, very good. If not, no problem. I will give you a short introduction in these technologies. And today is more about how to combine these, to test your application, to see if the application behaves as expected. So if you expect some, let's say, deep dive in one of these technologies, I think there are better sessions during the JCon, which will explain you in detail how Quarkus works, etc. Today is rather, let's say, from a user perspective, how to use these things and see how things behave. I will try to give you a practical introduction. So we're gonna switch to code rather soon and see how to implement a service and, as already mentioned, how to test parts of your service. So that's what you can expect from this session today. And with that, I come to my, let's say, disclaimer at this point. What you're going to see today is some things that work for us, things in which we believe are a good practice, are things that a technology stack or a testing approach that we think works for our setup. Of course, they might suit you for you, they might be appropriate for you, but on the other hand, I don't know your domain or your skill set or your technology skills or your whole team setup. So perhaps, or let's say, see it as inspiration today. I'm very sure there's something you want to dig in deeper after my session, but probably it's not the silver bullet for your problems. So it's just a short disclaimer up front. Okay. Before we go to have a look at Quarkus, I need to do a short excursus about resource efficiency, what it is and why I think it is important. Well, resource efficiency, in my definition, comes with two dimensions. The first dimension is your startup time, which means you want your application to start as fast as possible. And the second dimension is the memory consumption, which means you want your application to be really efficient with the memory, not use too much memory. Well, why is this important? Well, let's say if you create an old style EAR and deploy it to your application server and the process runs for weeks or months or even years, startup time probably isn't that really relevant. If your process runs for 2 months, if it takes 10 minutes to start it, okay, fair enough. But nowadays, you're more in this, let's say, distributed cloud environments. Perhaps you have some kind of microservices stuff where you say, okay, my cloud needs to scale fast if there are coming new requests. Yeah, if the requests come in, you need to scale horizontally and start new instances. And then it's not feasible if the instance takes 10 minutes to start. It needs to start now because the requests are here now. Or if you have some kind of CI/CD approach where you deploy to production several times a day, then of course, startup time matters if you deploy a couple of times a day. Or if you have a failover strategy, your cloud decides, oh, this service here looks broken. I start it over here. I start it again. So yeah, startup time matters in this distributed cloud environments. Even more if you're in a containerized environment like Kubernetes or stuff like that, where you don't have that much resources in your container. You normally just have one CPU and limited memory, etc. So yeah, it's even more important if you're going towards serverless, where you have this scale to zero approach, where your first request triggers your function or your service. And well, if that takes 5 minutes to start, that's not appropriate. So normally from a developer perspective, you don't get too much into contact with these, let's say, rather base things like startup time and memory consumption. So I think it's very useful to have a framework that takes care for this stuff. And one framework which does this is Quarkus. Or one step back, a nice tweet I found: the less efficient your application is, the more profit the cloud provider makes. And obviously, you don't want to spend too much money with the cloud provider. And one framework which helps you to be efficient or to be resource efficient is Quarkus. And Quarkus describes himself as a supersonic subatomic Java. And in these words, there's already a lot in. If you look at supersonic, which means very fast, for example, concerning startup time, and they say they are subatomic, which means very small, for example, concerning their memory consumption. Okay, let's see what else is Quarkus about, or how they define themselves. They say they are a Kubernetes native Java stack tailored for they have two target platforms, the OpenJDK and the GraalVM, which means you can create just a regular JVM application, but they have built-in support for the GraalVM, which allows you to create native images, which allow you to get your startup time and memory consumption even to another dimension. So a little bit out of scope today. Today, we just created a JVM application and test parts of it. And they say they are drafted from the best of breed of Java libraries and standards, which means especially if you have some kind of JE or Jakarta IE or perhaps microprofile background, you will find lots of libraries you already know, like Excursus or Hibernate, stuff like that, and can reuse your skills. So you don't have to learn a completely new technology stack. Everything you already knew can be used within Quarkus. They have this, I already kind of mentioned it, a container first philosophy, where they reach to get small size on disk, fast startup time, and low memory consumption. And how do they do this? Well, let me compare Quarkus to Spring Boot, because they say they place themselves as an alternative to Spring Boot. So let's see what they do different. Spring Boot is a very powerful framework, but they resolve their framework logic mainly by reflection, runtime proxies, dynamic class loading, class path scanning, stuff like that, which is very powerful and good to build a framework. On the other hand, these features come at a price, because they are done at startup time and at runtime, which means they have impact on your startup time and your memory consumption at runtime. And Quarkus and other frameworks like Micronaut, for example, say we don't resolve our framework logic at startup time or runtime. We shift that forward and do it at build time, or to be more precise, at compile time, which means they have an ahead of time compilation approach where they say when your application starts, everything is already there. So that's rather short. That's the main difference between frameworks like Quarkus and Micronaut to Spring Boot. Okay, one last sentence to Quarkus, because we're going to use that later on in the example. The dependency injection of Quarkus is based on CDI. If you ever used JE or Jakarta IE, you perhaps heard that already. Context and dependency injection, yeah, we're going to see that later in our example. Okay, that's for short to Quarkus. Let's have a look at the next library we're going to use, JUnit. I assume most of you have used JUnit or at least heard of it, as it's more or less the de facto standard for testing applications in the JVM world, or like they say, shaping the future of testing on the JVM. Well, at least since the latest version, the fifth major version, it's really programmer friendly, and I can really recommend having a look at it if you didn't have already, and use it for your applications. The good thing is, as you're going to see later, we create our application with Kotlin. From a Kotlin developer perspective, JUnit feels almost the same as it does as a Java developer. So I'd say, yeah, 99% of the things work the same. There are some tiny bits and pieces you need to consider, and we're going to see one of them later in our example. But from a very high level, you say for Kotlin, JUnit works the same as Java, and it works fine. And the last library we're going to use today is MockK. So perhaps you have already used something like Mockito, a very common and very good framework to be used in the Java world, where you can mock parts of your application or parts of your app and say, okay, I'm going to test only this part, and this is mocked away. And there is an extension for Mockito for Kotlin. The problem is that some parts of Mockito somehow contradict the approach of Kotlin, or the other way around. For example, every class in Kotlin is final. And Mockito has this approach to extend, to build stuff around or extend your classes, which somehow is a little bit hacky if you want to use Mockito with Kotlin. And the good thing about MockK is it is built from scratch for Kotlin. So it's a better fit than Mockito. I don't say Mockito doesn't work, but MockK is the better fit. So if you start using Kotlin and try to mock stuff, I can highly suggest having a look at MockK. You're going to see it has a nice DSL to describe mocking behavior. And it also allows you, for those who are already familiar with Kotlin, it allows you to mock extension functions and stuff like that, which is rather hard doable with something like Mockito. Okay, that's it with the introduction. I'm going to show you the application we're going to see in a minute and the test we're going to write. Just have a sip of coffee here. Okay. I stripped down the example application to the very basic because I don't want to spend too much time explaining the whole domain and what we are doing. So you're going to see it's a rather trivial example, but it's sufficient enough that you're going to see how to mock things with Quarkus. So first of all, we have a Quarkus application created with Kotlin, and it's a superhero registry. What does the superhero registry? You can manage your superheroes. So we have some registry where there's Batman and Superman and Wonder Woman and Black Panther, etc., which you can store and retrieve from our superhero registry. So let's have a look at the architecture. On the left-hand side, we have some service consumer, for example, a single page application or anything like that. And here we have a superhero resource, which is our REST API. In, let's say, in Spring Boot, it would be a REST controller, or in Micronaut, it would be a controller. In here, as we use JXRS, it's a superhero resource. It's our REST API. The REST API going to use itself a superhero service, a CDI bean. There's our business logic. Well, business logic, you're going to see it's not really much logic. It's just sufficient enough so we can test something. Yeah, and the superhero service itself uses the superhero repository, which is also a CDI bean. And perhaps you know the repository pattern if you have used Micronaut data or Spring data, or perhaps GORM, the Groovy Object Relational Mapping, where you have this, let's say, very convenient option to get all your CRUD operations just from the framework. We see that in a bit. Just remember that this whole data abstraction layer here is realized with a repository, and our superheroes are stored in a relational database here. And what is a superhero entity? You see here, probably the font might be a little bit too small, so I'm going to say to you that a superhero has 5 attributes. The first one is the ID. The second attribute is the name, like Batman. The third attribute is the location, because Batman is situated in Gotham City. The fourth attribute is his real name, because behind Batman there's Bruce Wayne. And the fifth attribute is his occupation, because Bruce Wayne works as a businessman. And now comes our, let's say, business logic in here and says, okay, we can't hand out here to any consumer that behind Batman there's Bruce Wayne. So we need to anonymize our superheroes, and we just hand out here that a superhero is, his name is Batman and he lives in Gotham City, and not that that's Bruce Wayne and he's a businessman. So that's the business logic we're going to test in a minute. Okay, so that's it. What we're going to create later, I'll show you the application first and we see if it works. And then we create a test for the superhero service and mock our repository. And later on, we're going to create a test for the superhero resource and mock our superhero service. So that's what we're going to do now. So I switch to IntelliJ. So this is already the application I created earlier. And yeah, we have a look at it and see if it works. So this is our superhero resource. Yeah, as mentioned, the REST API. In Spring Boot, you would have here a REST controller, something like that, which just say, okay, this runs on a certain path. And if you call superheroes / with a path parameter ID with the HTTP verb get, this function is executed. So we extract the path parameter and call the superhero service. and hand it over there to another function, find superhero, and over the ID. So the superhero service is here wired via constructor dependency injection. And yeah, we're going to have a look at that in a minute. So we have two more functions here. If you call superheroes without any path parameter, we return all superheroes. And here you have, if you call the superheroes with a post, we extract your body, your JSON, and try to create a new superhero and just return status code 201 created. So for the moment, let's focus on the first function here where we say, okay, we try to call the service. And if the result wrap it in a response code 200, okay, and return that to the caller. So as mentioned, this thing here is wired via constructor dependency injection. Let's have a look at this. And here you see the superhero service itself is annotated with application scope. And this marks it as a CDI bean. So application scope somehow is like a singleton. It exists in the whole application one time. So the superhero itself has another bean wired here, our superhero repository. And as mentioned, for the moment, we focus on the find superhero, just calls the repository find by ID. So let's have a look at the superhero repository. Also a CDI bean marked as application scoped. And now here you see, this is just an implementation of the interface panache repository. This is the whole repository approach I mentioned earlier, where we say, okay, this repository manages superheroes. And if you look here, a superhero, well, in Java, this would be a POJO with getter, setter, hash code equals to string, clone, copy, whatever you need. With Java 16, you could use a record, and in Kotlin, you just use a data class where you say, okay, this is my entity. It has an ID, it has a name, like Batman. It has location, Gotham City, a real name, Bruce Wayne, and the occupation is businessman for Bruce Wayne. So this is our superhero, which is managed by our panache repository. And here we just implement this. The column here means implement or extends. And this is a class and this is an interface. It's an implements. And by doing this, we get this find by ID or this list all, stuff like that, by convenience. We don't have to take care. I can look at here. You get a lot of methods already for your CRUD application, like list and persist and stream and whatever you want. Delete, you get that already built in. Okay, so this is the repository. You could add here your own functions, of course, or your own queries or something like that. So for the moment, for our rather trivial example, we don't need that, so sufficient enough. Okay. One thing I forgot to mention, if you have any questions, I'm not really good at looking at the chat. So just write your questions in the chat and I will try to answer them at the end of my session. Yeah. So if I don't see them, no worries, they won't be forgotten. Okay. Coming back to our repository or coming back to our superhero service here, if we retrieve a superhero from our repository, we call an extension function here, which is called anonymize. And this extension function says, okay, we take the whole superhero and just return an anonymized superhero, which is only a name and a location. No more the real name and the occupation of the Bruce Wayne and businessman is left out. So, and this is handed back again to a REST API and given to the caller. So I think the application should already be running in the background. And if I call here localhost 8080 superheroes, oh, one thing I forgot. I created a small starter bean. This is nothing you would do in your productive code. This is just a bean that is executed every time I start my application and already inserts 5 superheroes for me, so I don't have to create the test data every time. We already have Superman, Batman, Black Widow, Black Panther, and Spider-Man here. And you see Black Widow is Natasha Romanoff. And if I call localhost 8080 superheroes, I just see that Black Widow is from Volgograd and not that it's Natasha Romanoff. So yeah, our business logic works. And if I just call localhost 8080/superheroes1, I just get back Superman from Metropolis, and I don't know that it's Clark Kent. So, okay, switching back here, application is running. I'm just going to stop it to create some tests now. Okay. First of all, I want to create a test for this superhero service. So let's create a test here, create new test. And To save them time, instead of typing, I created a live template here. And let me give you just a short introduction. What you're going to see here is probably all of you know the test pyramid, where it said you need to have lots of unit tests because they're easy to implement and they're executed really fast. And you need to have some application or integration tests. They take a little bit longer to be executed and a little bit harder to implement. And at the top, you have a couple of end-to-end tests. And not too much. They normally just test your happy path. So everything you tested below your units, they work together as well. So first of all, let's start with a plain unit test. If we want to test our application, you see here, our superhero service test just says, okay, we have a testee, our superhero service, and we're going to mock our superhero repository. And here you see this is MockK. We just say create a mock for this superhero repository. And as we use constructor dependency injection, we just can, in a unit test, we can say, okay, instead of wiring something or whatever you do, just take this mock I created here. And then you see here, JUnit at test, we just define a test function. And this is the whole test function. And you see, if you're not familiar with Kotlin, you can write your function names like this. You don't need uppercase, lowercase, camel case, snake case, whatever. You can write it with blanks here, what you probably won't do in your productive code. But as this is only a test function, which is never called explicitly by me or by my application, only by JUnit, this is a nice way to, at least you don't need the at display, which you perhaps know from JUnit. So, and then if you look at the test, it's written in the AAA pattern, which means arrange your test. So describe your mocking behavior. We say for every call of the repository find by ID, we're going to the repository, the mocked repository, will return a superhero with these parameters. Then comes the second A, the act. So we're going to execute our test and call really find superheroes. And at the end, there's the assertion, the third A, expect that. This is the Kotlin library for assertions. If you use SRJ, that would be assert that. And just say, we expect that the result is equal. We return this whole thing, but we only see that there's mocker and mockcity. So let's run this and see if it works. Okay, take some time to compile. And as usual, as soon as you start streaming or sharing your screen, everything else on the machine is rather slow, but it's still a unit test. It should be executed in an acceptable amount of time. Normally it takes milliseconds to run this. And just to show you it really works, if I do here, if I put in here a bug and say, instead of the name, Batman, copy in the real name, and we rerun it. It should fail, yes, because it says, okay, you exposed the real name and not the superhero name here. So I'm gonna fix that. Okay, so far so good. And to be honest, if I only want to test my business logic, this plain unit test would be sufficient enough, I think. So to show you how really test Quarkus applications, I need to add something which we also want to test. And this is this cache result here. So what I say here is cache this answer. If this method is called the first time with a certain ID, call the repository. If it's called the second, third, fourth time, use the thing from your local cache. So big disclaimer, this is not a good example where you introduce caching, the complexity of caching, because this is a trivial database operation and your database is really fast in doing that. But caching is a good example you're going to see in a bit to show you how to test parts of your Quarkus application. So bad example for caching, good example for showing you how to write Quarkus test. Just imagine this would be a really, really expensive database application, or perhaps another service you call, which has rather constant data, which only changes once a day, and you want to cache that in your local repository. Because now we can say in our test, we want to see if caching works. We have annotated this function, but we don't know if caching works. And we say, and see if caching works. And for that, we need to rewrite our test a little bit, and we just call it 2 times here. result 1 and result 2, and we still expect that result 1 is like this, and then we expect that result 2 is equal to result 1. And now with MockK we can say and verify that our repository, repository find by ID 42 is called only once, exactly once. We call our service 2 times, but the service itself should call the repository only once. So let's rerun this. And while it still compiles, I can already spoil it a little bit. This won't work this easy because it says, hey, you called your repository 2 times. The mock was called 2 times, and you say, I only want it to be called once. Yeah. Obviously, this annotation, this annotation is a Quarkus annotation. And with my plain small unit test, my unit test knows nothing about Quarkus. So I need to promote my unit test to a more application, or let's say integration test, and say here, we saying this is a Quarkus test. And now we don't want to instantiate here our testee. We just say private val late, come on, late in it, and say here add inject. So we say, okay, this is a little bit, if you're familiar with Spring Boot, this was kind of the same as Spring Boot test, or in Micronaut, it's Micronaut test. Start the application, and we're going to use the real CDI bean here and see if that behaves as expected. So let's rerun this. And you're going to see this is already takes longer than the plain unit test, because Quarkus is started in the background with all the modules I have defined to be started. So yeah, normally it starts really fast. That's one of the advantages of Quarkus, that it starts fast. But as mentioned, when sharing your screen or streaming anything, everything gets annoyingly slow. Okay. So first of all, what we want to show you is it starts here. Quarkus is started in the background in almost 8 seconds. Normally this starts in about 1 second. And you see all the features I have installed, but the test fails as it says, okay, you expect here that the result is the mocker, and it returned null. Yeah. And the reason for that is, okay, we use here our CDI bean, but we use everything else from the Quarkus application, and that we have defined our mock here. Quarkus knows nothing about this mock. This is just the mock in our unit test. So somehow we need to say, hey, Quarkus, instead of using the superhero repository CDI bean, please use the mock I have created in my test. And therefore comes here. Okay, we use it. We just say with JUnit before all, execute this function before any test is executed. Set up mocks. And now you have let's say a small tool, Quarkus mock, where we say install mock for type, repository for superhero repository. Yeah, I started and explain you what happens. We say before any test is executed, hey Quarkus, use our mock we have defined here instead of the real CDI bean you already have. Okay, it still fails. Okay, now we don't get any Quarkus or assertion error. We get an error from exception from JUnit. It says the before all method needs to be static. So if you think back, I told you JUnit from a Kotlin developer's perspective works almost the same as for Java developer. There are some tiny bits and pieces you need to consider. And one is that static behavior in Kotlin is different than static behavior in Java. And what we need to do here is just say, okay, we create a companion object and put this in a companion. Oops, sorry, wrong direction. Put this in a companion object. And now with the companion object, I'm allowed to say here JVM static. which says, I started, and while it's been executed, I tell you what JVM static does. JVM static says to my Kotlin compiler, create also a static function or a static method for this in here. And with that, JUnit should be fine and say, okay, I find my static function. I can use the before all and tell Quarkus to use my mock instead of the CDI bean. And cross your fingers, our test works. So let's have a look to wrap it up. We tested our business logic, and we tested if caching works. And for that, we created a mock of our superhero service, and we said to Quarkus, use this mock instead of the real repository. So this is a good way to do this, but to be honest, I'm not really satisfied, because here you need to write more code when you use Kotlin than you would need to if you use Java, and that is rather uncommon. Normally, Kotlin has a more, let's say, concise or idiomatic way of writing code, and this is, I don't like this here. And with this, I want to introduce you to an extension, the Quarkus MockK JUnit 5 extension. You see it's from the Quarkiverse, a place where new extensions are created. And yeah, just to say it up front, it's in version 0.2.0. It is not that well maintained, and there are only 6 contributors. Well, to be honest, there's mostly one guy behind this, created this. It's not the best maintained extension, but it works very good. And I don't think what else you would need, because switching back to here, if I use that, we can get rid of this. Oops, no, not completely of this, but of this. We don't need this whole thing here. We don't need this. We just switch this to a late init var, remove this, and say here, add inject mock. Here, see, this is already from Quarkiverse, test JUnit 5. And this is it. I restarted. So now we have a very declarative way to say, hey, create a MockK mock for me and inject that in my Quarkus application. And normally you don't have this one mock in your test. You have 2 or 3 mocks perhaps. And I think this is a very neat way, a very short and handy way to describe things. Create my mocks, inject them, then take my testee, and then I can run my tests against it. And it still works. So yeah, very, very declarative, easy way to describe your test. I think it's very readable. So, okay. That's it for the superhero service. To complete this, we just create a test for the superhero resource. So for our REST API, I also created a live template. So let me explain what's going on here. Of course, this is a Quarkus test. If you look at here, everything we want to test is this must be reachable with HTTP verb get. You want some JSON serialization or deserialization. Everything that is done by the framework. So testing this with a plain unit test does not really work. So of course we need a Quarkus test here, and we want to mock our superhero service. And we use the extension I've shown you, and say just inject mock, create a mock and inject that into my application. And then we have here, once again, with the kind of the AAA pattern, we say, okay, first arrange our mocking behavior. If the superhero service, the mock of the superhero service find superhero is called, just return an anonymized superhero. And okay, this can be done a little bit better readable. Inject language, JSON. So arrange our test, and this is rest assured, this is nothing Quarkus or Kotlin specific. This is the act part we call superheroes/42. And this is the assert part where we say, and then we expect that the status code is 200 and that we retrieve some JSON, and the JSON we retrieve is this one I defined here. So let's run this. Once again, Quarkus is started, your REST interface is there. We do a real request against our REST interface and see if it behaves as we want it to behave. Okay, worked. So let's add another test. I just copy this and say We also want to test if we get a 4 or 4 for an unknown ID. So here we don't return that. In this case, our repository, our service doesn't return a real superhero, but null. We don't need this, and we also need these two. And we just say, okay, I don't know if this is proper rest, but we say if there is no superhero, no superhero can be found, we expect the status code to be 404. We run it again. Okay, and this test fails, yes. Why does it fail? We get a 200 instead of a 404. So if we look again at our superheroes resource, yeah, that's true, because we just wrap every response or every answer from our superhero service with the status code 200. So what we need to do here is, change our implementation and say superhero resource, well, superhero resource, superhero is this, and if superhero is not null, we return a okay. Oops, with the superhero in here. And if it's null, we just return a response.status not found build. And of course, we need to return this and rerun our test. And cross your fingers, now it should work. Okay, so one thing I need to mention here is first I created my application and now we're adding the test afterwards, which is normally not that best advice you should do. Normally you start with the test and then create your applications. From a demo purpose, it was easier that way around. So, but now at least we have a test and could do refactorings, because refactoring stuff without having tests is like, Russian roulette. It might be okay, but you could shoot yourself. And as we have a test now, we could write here this with the, I think this is a good way to describe that. It's really readable with this if-else statement. But if you're familiar with Kotlin, we can describe, well, let's do it this way. We can write this a little bit more Kotlinish and say, use an extension function and scope function here and say let, and then superhero response. Okay, and use an else operator here and say, if not, return this and just return this. So this needs to be removed. So, and now we can rerun our test because we have a test. We can refactor this and see if the application still behaves as we want it to behave. So yeah, if you're not familiar with Kotlin, don't be surprised here. This is just, you need to write a little bit less code, but the other way with the if-else statement. Perhaps if you have team members which are not really familiar with Kotlin, the if-else statement would be much more readable. Okay. This is it. So I'm just going to switch back to my slides to wrap it up. Well, what we've seen so far, we created a test for our superhero service by mocking the repository, and we created a test for our superhero resource by mocking our service. What I don't do is create a test for the repository. Just show you why. Because our repository has no real function in there. We just use framework code, and I don't test that. If I would have here my own function, it needs to be tested. This way, I don't need to test this, at least in my beliefs. What is missing still is an end-to-end test where you just say, okay, I've tested my units here individually, and now I do a happy path here and say, okay, create one superhero and try to retrieve it in the same test. You can use test containers and stuff like that for that. Okay, with that, I'm coming to an end. Quarkus is a really powerful tool, really great framework with a lot of drive, lots of stuff going on there, great support, but you need, if you choose Quarkus, you need to consider some things. There are, as always, if you choose a technology, some drawbacks. Keep in mind, the framework is around here for about 2 years, 2.5 years, something like that. So it's rather new, which means it cannot have the feature completeness and the ecosystem of a framework that's been here for ages, like Spring or Rails. There's a lot of going on. They're keeping up, or the pace is incredible how they create stuff, but it cannot be there. And also some things I need to mention concerning the Kotlin support. Since version 2 of Quarkus, it's really good, the Kotlin support. But here you see at least from the if you scaffold your new project, they still say Kotlin is in a preview mode. And what you've seen here with Panache and Kotlin, it's still in an experimental mode. So far, everything I've seen works, but sometimes it's a little bit tricky to see if you have an error. Is it because I'm using Quarkus wrong, or is it something that does not work with Kotlin? Or yeah, so compared to the outstanding support of Spring Boot for Kotlin, there's still a little bit lag, but I'm confident they will keep up and fix that gap also. I mentioned the nice Quarkus JUnit 5 MockK extension, also with a little bit gap for maintenance considered, but works nice. And you've seen you don't need that much more to use that. And with that, I come to an end. If you interested in this whole issue or want to have a deeper look in it, I wrote a blog post about this whole thing where it's a little bit, I go a little bit more into details, which problems are also there, like if you're a Kotlin developer, perhaps you know this nested inner classes, which you like to use to structurize your tests, which does not work so far with Quarkus test. Of course, it works for your unit test, but not for your Quarkus test. And there are some more things I mentioned in this blog post. You can find my GitHub repo. Looking forward to your questions now. And if you have some more questions, find me on Twitter. My DMs should be open. Just get in contact with me. Thanks. Have a nice day at the JCon and looking forward to your questions. So I look at the chat. I think there is already something. Okay. Need to end my slideshow here. The chat. Okay, this was just that I can start. Is there any other question here? Don't want to oversee it. In that case, just unmute yourself or re-ask them. I'm not sure if I've missed something. Otherwise, I just can describe, if you're interested in that, a problem I had yesterday evening when preparing the demo for today. I just thought, well, okay, what can go wrong? I just switched to the newest version of Quarkus 2.3.0, should that be? And unfortunately, that did not work. And that was one part where I'm not sure if it's the combination of Quarkus and Kotlin that did not work, or was it a special thing because it had something with the code generation and Hibernate? Was it the setup of my project? And this is something, yeah, just keep in mind when switching to this framework and also using Quarkus, there might be some small bits and pieces you need to consider. Yeah, it's leading edge. So great framework. Sometimes you need to dig in a little bit deeper to understand everything. Okay. Thanks. Nice talk. Good introduction. That's very kind of you. Hope it was not too confusing with all the failing tests you've seen. But yeah, as always, start with the plain unit test, then add or promote it to a Quarkus test. If you see, oh, I need some kind of application here to test it. And at the end, you have some, let's say, end-to-end test if you need that. So that's an approach we really like. Yeah. Can I get the project file? I mean, POM XML? Yes, of course. if I know how to send it to you. I can show it at least here, the POM. But it's you. I don't know if you're familiar with Quarkus. It's Quarkus.io. You can generate your project here. I've done it mainly this, and here you see what I've defined is I use a certain Kotlin version, and here I should use a certain Quarkus version. And the rest is just plain what I've generated. Yeah, I need to add MockK, of course. I need to add this extension. Yep, but I can give it to you. I'm just not sure how to get it. But if you contact me, perhaps per Twitter or something like that, I will send it to you this morning, definitely. Okay. Join breakout room. So I'm going to join the breakout room. Thanks again. Enjoy your day at this great conference and have fun today. Bye-bye.